When a wave passes through a medium, such as light passing through air or glass, it is known as transmission. You know that sound and light most often travel in straight lines, and that they travel at certain speeds in certain media. Waves transmit well through a medium when the path and speed of the wave are not changed much by the medium. When waves travel in straight lines, it allows you to judge where objects are. However, if a wave changes speed, it does not continue in a straight line. Since the path of the wave changes, the wave bends, and objects may appear to be where they are not. When a wave bends as it transmits through a medium, it is known as refraction. Refraction occurs when a wave bends as it changes speed moving through a different medium. When sound and light waves refract, the paths of the waves change, so things may look or sound different. Notice the spoon in this glass. The light waves have one speed in air and a different speed in water, which causes them to bend. This makes the spoon appear to be in a different position. There is refraction of the light waves when they meet the water of the fish tank and in the glass, because there is a change in wave speed moving from air to water, or from water to air. Click on the Causes of Refraction button to learn more. For a wave to refract, two things must happen. First, the wave must change speed. If a wave does not change speed in a second medium, the wave will continue in a straight line and will not bend. When a wave increases its speed, it refracts away from the imaginary normal line. If the wave speed decreases, it bends toward the normal line. The second thing that must happen for a wave to refract is that the wave must enter the new medium at an angle. If a wave moves straight into a medium perpendicular to the surface, the wave will change speed, but it will continue in a straight line. It will not refract or bend. Moving into a medium at an angle causes waves to bend. Some waves meet the surface first and change speed, while the rest of the waves continue at the previous speed in the other medium. Once all the waves have entered the new medium, they continue moving in a straight line. Click to review the causes of refraction, or click Continue to move on with the lesson. You are probably less familiar with the refraction of sound than the refraction of light. You won't usually hear sound refract because human ears detect most sounds in one medium, air, under fairly constant conditions. Maybe you have been under the water in a pool and heard someone who was not underwater call to you. The caller's voice sounds different because of refraction. Sound travels faster in water than in air, so the sound bends or refracts and speeds up as it moves from air into water. You may not realize it, but sound waves also travel faster as the temperature of the medium increases. If a medium has areas where the temperature is different, refraction of waves can occur. You can often hear sounds from far away better at night because colder air near the ground bends the sound waves towards you, as shown on your screen. During the day, the warmer air near the ground would bend the sound waves away from you. Regardless of the cause, when any wave bends because of a change in speed, it is known as refraction. The more the speed of a wave changes, the more it is refracted, or bent. Certain objects refract or bend light in interesting ways. You may already know that certain crystals, called prisms, and drops of water in the air can separate light into rainbows of color. You see light waves with different wavelengths as having different colors. White light is actually made up of the 7 colors you see in rainbows: red, orange, yellow, green, blue, indigo, and violet. If white light shines through a prism or water drops in just the right way, refraction separates light waves by wavelength and causes a rainbow to appear. Light waves at the blue end of a rainbow are refracted most. Red is refracted the least. Remember, refraction has to do with a wave changing speed. You may wonder how a prism differs from a glass window. When sunlight shines through a window, it doesn't usually form a rainbow. Why not? The difference between a prism and a pane of glass involves the 2 surfaces that the light passes through. In a prism, the 2 surfaces are at an angle to each other. In a pane of glass, the 2 surfaces are parallel. When 2 surfaces are parallel, they are the same distance apart, so that they will never touch. When light passes into the glass, it refracts. However, when it leaves the glass, it is refracted back in the opposite way, so that the light that passes out of the glass is similar to the light that first hit the window, but in a slightly different place. After passing through the glass, the light travels in the same direction, and the wavelengths of light recombine. In a prism, light bends once when it enters the prism, and again in another direction when it leaves, spreading the wavelengths of light farther apart. Unlike light from the pane of glass, the waves of light do not recombine when they leave a prism, which is why you are able to see the separate colors of the rainbow. Now, to learn about absorption, click on the absorption box.